Fundamentally, HSMs get classified by two main things: what they do their function, and then where they live, how they're deployed physically. And it's interesting because the function often dictates, everything else, the features, the specific certifications they absolutely need. It's definitely not one size fits all.
Right. That makes sense. So let's start with function then. First up are general purpose HSMs. Sounds pretty broad.
Yeah, the name kind of gives it away. These are the versatile ones. The workhorse is designed for a whole range of crypto operations. You see them across loads of different industries.
And what makes them so adaptable? What are their key traits?
Well, they tend to have high performance. They support a wide range of algorithms, your RSA, ECC, AES, SHA standards. And crucially, they have flexible ways to connect with software, like through APIs such as PKCS Shaft 11. That standard makes it easier for applications to talk to the HSM securely. Plus, they almost always have strong FIPS 142 or 143 certifications. Public Key Infrastructure, or PKI. You know that little padlock icon in your browser? Every time you see that securing a website, well, there's very likely an HSM working behind the scenes. It's protecting the root keys for the digital certificates that let you trust that website, or trust that an email is legit. Without HSMs guarding those keys, well, the whole system of online trust starts to fall apart.
That's a really good point. It's not just websites, though, is it? What about, say, software downloads?
Exactly. Code signing is another big one. HSMs ensure the software you download is actually from the publisher and hasn't been messed with. Protects you from malware. Same idea for document signing, ensuring legal documents haven't been tampered with.
And our personal data sitting in databases.
Yep, database encryption relies heavily on them too, especially with things like transparent data encryption, or TDE. The HSM protects the keys that encrypt the data. So even if someone steals the database file, the data is useless without the keys, which are safe inside the HSM.
That really reframes database security. It's all about protecting the keys. And what about in the cloud? I hear bring your own key or BYO mentioned a lot.
Right, BY is a strategy where companies use their own HSMs, often on-premise, to generate their master encryption keys. Then they securely import those keys into a cloud provider's key management service. It means the company, not the cloud provider, holds the ultimate control over their data's encryption keys, even if the data lives in the cloud. It's about maintaining control.
Makes sense why big organizations would want that. They also use them for managing keys across the whole enterprise, right? Centralizing everything.
Precisely. It simplifies security and helps with compliance. You'll see vendors like Thales and Utamako as big players in this general purpose space.
Okay, so if those are the versatile ones, payment HSMs sound much more specific, tailored for finance.
Exactly. These are highly specialized for the financial services industry. Think banks, payment processors. They have to meet incredibly strict standards set by the payment card industry, like PTS HSM certification. That's non-negotiable.
What makes them different functionally?
Well, they're built for blazing speed, very high transactions per second, or TPS, and they perform specialized payment functions like translating peon blocks securely or generating EMV cryptograms for chip card transactions. Those cryptograms help prevent fraud for each purchase.
So this affects you directly, listener. Every time you swipe, tap, or click to buy something online, these devices are securing that transaction.
Absolutely. They're also essential when banks issue new cards, managing the keys for chip and magstripe cards, and of course processing your PIN securely when you use an ATM or pay in store. It's all about secure payments and fraud prevention.
And it all ties back to that PCI DSS compliance, which is mandatory.
Correct. Companies like Thales with PayShield, Diamaco with Atala, they're key providers here. Even cloud platforms like Azure offer specialized payment HSM services now.
Okay, that distinction between general purpose and payment HSMs is clear. Let's shift gears now to the second classification, where these HSMs actually live, their deployment model or form factor.
Right. This is all about how the HSM is physically plugged into the IT setup and
Yeah.
how you access it. It affects performance, scalability management, all sorts of things.
So kicking things off, network-attached HSMs, sometimes called appliance HSMs. These sound like a common starting point.
They are very common, yeah. These are basically standalone boxes, hardware appliances that connect to your network. The big advantage is that they can provide crypto services to lots of different applications or servers centrally.
Centralized management sounds like a plus, especially for bigger organizations.
It is. And they offer good performance. They scale well. You can have partition them or cluster them together. They also support multi-tenancy, which means different departments or even different customers, if you're a service provider, can share the same HSM securely.
So big companies might use them for their internal PKI or service providers offering HSM as a service.
Exactly. Or for offloading SSL/TLS encryption for busy websites. Think vendors like Thales with their Luna Network HSMs or Utamako with Crypto Server LAN.
Okay, next up, PCIe HSMs. These sound different, like cards that go inside a server.
That's exactly what they are. They plug directly into a server's motherboard using a PCIe slot. Think of it as embedding the crypto power directly into that one machine.
So less about sharing and more about dedicated power.
Precisely. The big benefit here is very low latency and high performance dedicated just to that server. It's tightly integrated and can be more cost effective if you need that dedicated horsepower for a specific task.
Like what kind of task needs that?
Maybe maximizing HTTPS performance on a web server, or high-speed crypto for a database server. Also, manufacturing, sometimes they're used to inject keys directly into IoT devices as they're being made, or in specialized systems like industrial controls or medical devices where that low latency is critical. Again, Thales, Utamako, and Trust offer these card-based HSMs.
Got it. Then we have something quite different. USB HSMs, portable ones.
Yeah, these are small devices, kind of like ruggedized USB sticks. They connect via USB, generally lower performance, but still offer really high security. Portability and cost are key selling points. And they're often used for specific, sometimes offline tasks.
Offline. Like what it's...
Think about protecting the absolute most sensitive keys, like the root keys for a big PKI. You might store them on a USB HSM kept in a safe, completely disconnected from any network, what we call air-gapped. Makes them incredibly hard to compromise remotely. Or maybe a developer using one to securely sign their code. They're also used for things like strong admin authentication or smaller bring-your-own-keys scenarios. You might see ones from Thales and Trust. Even YubiKeys offer some HSM-like functions.
Okay, interesting. Now, inevitably, the cloud HSMs or HSM as a service.
Right, so here the HSM hardware is hosted and managed by a cloud provider like AWS, Azure, or Google Cloud. Organizations essentially rent access to HSM capabilities without having to buy or manage the physical hardware themselves.
What's the main draw there? Is it just avoiding the hardware hassle?
That's a big part of it. Reduced operational overhead, shifting costs from capital expense, CapEx, to operational expense, OpEx. But also, you get the cloud benefits. On-demand scalability, high availability, disaster recovery handled by the provider, and it integrates smoothly with other cloud services.
So this is great for companies running fully in the cloud or wanting that pay-as-you-go model.
Absolutely. Perfect for cloud-native applications, handling variable workloads like e-commerce spikes, ensuring consistent security across multi-cloud setups, and meeting compliance needs like GDPR or PCI DSS within the cloud. All the major cloud providers offer these services.
And finally, you can mix-match, right? Hybrid HSM setups.
Yes, and this isn't a product type, it's more a strategy. Combining on-premises HSMs with cloud HSMs, it's about finding the right balance. Maybe you keep your absolute most critical crown jewel keys on an HSM you physically control in your data center, but use cloud HSMs for scalability and flexibility for other applications.
So like for a gradual move to the cloud, keep the root keys on-prem first.
Exactly. Or for robust disaster recovery, mirroring your on-prem keys to the cloud. Or maybe data sovereignty rules mean certain keys have to stay within a specific physical location. It gives you flexibility for complex environments that have both legacy systems and new cloud stuff.
Okay, wow. That's quite a tour through the HSM landscape.